Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in today's class, this is the last class regarding the sound. Today we are going to discuss two or three terms related to the sound. Okay, so what are those two terms? Let us see. Say, as I have said, that sound is produced by any vibrating body. Any body which is vibrating, that is, you can say, that is moving to and fro, can produce sound that we are able to hear. But here is a small thing that you must know. As I think I have told this in the first class also, that if we just move the pen about like this, then it should produce sound, because the pen is moving, that is vibrating to and fro. Okay, to and fro, to and fro. But generally when you move this pen like this, you are not able to hear any sound. Why? What is the reason behind this? The body is moving, but you are not able to hear any sound. So what is the main reason behind this? See, here the main thing that works is that our ears are sensitive to certain frequencies only, or say rather a certain range of frequencies. That is, we cannot hear those sounds which are produced by the source which is moving at a frequency either say lesser than or greater than that particular range. Okay, so what is the range that we can hear? We can hear sounds which are produced or which are having a frequency from 20 Hz. Now you know the meaning of 20 Hz to 20,000 kilohertz, KHZ, kilohertz. Okay, so I think by now the thing Hertz is clear. If one vibration is completed in 1 second, it is said to be 1 Hertz. So 20 Hertz means any body which is vibrating at a speed which is say it's 20 times per second, then you can hear sound produced by those kind of vibrating bodies. And this is the minimum limit. So what is the maximum limit? There should be maximum limit also. If the body vibrates at a speed of say around 20,000 times a second, then up to that range you can hear the sounds. But if a body vibrates at a say speed which is greater than this, that is, the body is vibrating at a speed of say 30,000 times per second, then that kind of body will produce sound, but our ears are not able to hear it. Our ears are not sensitive to those kind of sounds. So basically you need to remember that we can hear only sounds which are of frequency from 20 Hz to 20 kilohertz. If the sound is less than 20 Hz, okay, so frequency is less than 20 Hz. So if it is less than 20 Hz, then this kind of sounds are called infrasonic sound. Okay, and what about if the sound is more than the frequency 20 kilohertz, 20 kHz, then it is said to be ultrasonic sound. So ultrasonic sound. Okay, so this is the frequency. Now we are not able to hear these kinds of sound which is infrasonic or ultrasonic in nature. Okay, however there are certain applications of ultrasonic sound. You know that very often times you might have heard that there is some stomach pain, or there are some different kinds of pain in different body, mainly the stomach region. Then doctors advise to do some test which is known as USG, and the full form is ultrasonography. Basically, that technique USG makes use of ultrasound to detect the presence of certain things in our body. Okay, so this is one of the applications of ultrasound. Also, you can see or you know that bats can fly very fast even in the dark without seeing. So how can they fly? They continuously produce ultrasonic sounds, okay, that we are not able to hear, but the bats can hear. Okay, now what happens? We have learned echo in the previous class. We have discussed echo. So ultrasonic sound, when bats produce ultrasonic sound, those sounds are actually very high energetic sounds. When they release these sounds, they move to a particular distance, and when these sounds hit a particular barrier in front of the bat, what happens? The sound gets reflected back. The bat can actually receive or hear the echo of that particular sound. In this way, the bat can understand, okay, that there are certain deflection or certain barrier in front, lying in front of it, and so it can change its path. So this is how actually a bat navigates through in the night without seeing. Even in the dark it can move so fast. Okay, so these are the use of ultrasonic sound. Another use, ultrasonic sound can also be used to find the depth of the oceans or river beds. Okay, how it can be done? Say, okay, so just let me erase it off and discuss this portion. That this ultrasound can also be used to detect the or determine the depth of the oceans. How it is possible? See, what happens? There are certain machines that can generate these ultrasounds, and they are directed towards the depth of the ocean. Okay, so say certain there is an ocean. Okay, and it has a lot of depth. Okay, like this, and so this is the ocean bed. Okay, this is the black line is the ocean bed. Okay, fine. Now a ship is moving to the surface of the sea waters. Okay, the ship carries the machines, okay, required to generate those ultrasounds. Fine. The ship generates an ultrasound. That ultrasound, when it generates and is being directed towards the down depth of the sea, some stopwatch is being set and it is started, and the sound goes like this. It hits the seabed and then it again moves back, and there is a receiver that can actually receive back this sound. So the time for this total thing to happen is being recorded, the moment from which the ultrasound was created and the moment at which the ultrasound is being received by the receiver. This total time period is being recorded on the timer or say a stopwatch. Okay, and you know that we can easily from various data we can know that what is the speed of sound in water. Okay, and so if you know the speed of sound in water, what is happening? If you consider the depth of the ocean to be d, okay, and say we have already recorded the time has to be t, then can you say that the depth velocity of the sound in water, okay, will be equal to this twice this depth by the time recorded on the stopwatch, isn't it? Why? Because the within that time stipulated time, the sound has actually traveled a distance of 2d. D it has gone down and d it has then again gone up. So from this we know the value of this velocity of sound in water. We know the time from the stopwatch, and then you can easily calculate the depth of the ocean d. Okay, so this is one of the application of the ultrasound. So I think the concept of ultrasound is clear. Okay, fine. Now, so with this we come to the end of this chapter. The theoretical part has been only covered. Okay, so if you have any query, any doubt, any problem regarding this, you can mention it in the comment box. We'll be happy to solve your problem. Next we will be starting the chapter current electricity. And that will be coming to an end, and we are coming to an end of the class 9 syllabus. I hopefully will be able to complete the syllabus within time. So, okay, if you have any query, any mention, please mention in the comment box. Okay, with that we come to the end of the class. Thank you. Goodbye.